My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Kumar Engineering College, Ghaziabad. Today, my today in this lecture we will discuss about the classification of operating system. This is the table of content that I will discuss in this lecture. Actually, operating system is classified in different types of system, and these systems are batch operating system, interactive operating system, multitasking and time sharing system, multiprocessing operating system, symmetric and asymmetric multiprocessing, and real-time system. So I will discuss about all these types of operating system, all these classification of operating system. So batch operating system. Actually, batch operating system is used at the time of the second generations of the computer system. During those days, what happened? The jobs which have the similar kinds of requirement, they are grouped into the batches, and computer operator load that batches into the computer system, and batch are executed one by one. During the batch operating system, the main drawback is that user doesn't have any interaction with the system. At that time, simple punch card were used. The programmer prepare his job and store their job or task on the punch card, and that punch card will be submitted to the machine operator, which is mainly the mainframe, and the punch card reader in the device read the instruction stored in the punch card of the program and load them into memory, and after that the processor will start to execute the memory. So in case of batch operating system, the main drawback is that the user cannot interact with the program. What happened during the batch operating system? Suppose there is job 1, job 2, and job 3. These jobs have the similar kinds of requirement. Then these jobs are grouped into batch. Suppose batch 1. Again there are another job, job 4 and job 5. And these jobs have another similar kind of resource requirements. So they are grouped into a different batch, batch A2. Okay. Now what happened? These batches are loaded into memory, main memory B1 and B2, and CPU start to execute the batch. Now, another important thing about the batch operating system is that suppose this is a batch B1, and this batch contains 3 jobs J1, J2, and J3. So once the CPU has started to execute the batch B1, then at first it will start the instruction of J1. Then when the J1 is completed automatically, then transfer is automatically, control will automatically transfer to the program next job J2, and after the completion of J2, the control automatically transfer to the J3. It means what is happening here? After completing a particular job, user doesn't interact with the next job. That is why it is said that in batch operating system there is no interaction of user with the system. Once the first job is completed, then control is automatically transferred to the next job, and after that control is automatically transferred to the next job. Okay. Again, the batch operating system is of two types: simple batch operating system and multi-programmed batch operating system. In case of simple batch operating system, the batch are loaded into memory one by one. It means at a particular instant of time, only one batch will be available in main memory. So when at first batch 1 is loaded into main memory, CPU start to execute batch 1 and execute all the jobs defined inside the batch 1. When the execution of batch 1 is completed, then the second batch B2 will be loaded into main memory. CPU start to execute the job defined inside the batch B2, and after that the next one. It means in case of simple batch operating system, only one batch is available in main memory, or we can say that batch are executed in one by one manner, one after the other. Whereas in case of multi-programming batch operating system, what happen? More than one batch are loaded into memory at the same time. Suppose we have 3 batches, B1, B2 and B3. Okay. So when CPU start to execute B1, then after completion of all the jobs defined in the B1, CPU will automatically start to execute B2. Then after execution of B2, CPU will start to execute B3. It means after completing the execution of all the jobs defined in a particular batch, CPU doesn't need to wait for the availability of the next batch into the main memory. So this is the advantage of multi-programming batch operating system. What is the term multi-programming? Multi-programming simply means availability of more than one program in the memory, or sometimes we say that execution of more than one program at the same time, that is known as the multi-programming. But exactly multi-programming is the availability of more than one program into main memory, so that we can increase the utilization of the CPU. It means in case of multi-programming, our basic objective is to increase the utilization of the CPU, because when the CPU finish the execution of a particular batch, then it doesn't need to wait for the availability of the next batch in the main memory, since there are more than one batch available. Okay, so after finishing the execution of a particular batch, CPU will automatically start to execute next batch. Whereas in case of simple batch system, when we load first batch into main memory, CPU execute it. After the completion of that batch, CPU need to wait for the availability of the next batch or next job in the main memory. So that is why in case of simple batch operating system, CPU is not utilized properly. Whereas in case of multi-programming batch operating system, CPU is utilized properly. So the objective of multi-programming is to increase the CPU utilization of the CPU, and the number of programs or number of batches available at a particular instant of time in main memory, that is known as the degree of multi-programming. Okay. So in case of multi-programming, multiple jobs are available in main memory. So multi-programming environment, when a processor complete the execution of the first job, then next job is available. So it doesn't wait for the availability of the next job in main memory. Okay. So this is the multi-programming. Second one is the interactive system. Interactive system, the main drawback of the batch system is that user doesn't has the interaction with the system. It means batch operating system doesn't support the user interaction with the program, whereas the operating system which support the interaction of a programmer or interaction of the user with the program during its execution, that type of system is known as the interactive system. Nowadays, most of the systems such as the operating system, Windows, Linux, these are the interactive operating system. So interactive operating system support the executions or support the interaction of user with the execution of the program or with the program during its execution. Next one is the time sharing system. There are two terms. First one is the multi-programming. Next one is the multitasking. Multi-programming and multitasking. Sometimes this is also known as the time sharing system. Okay. So this type of system, time sharing system, is also known as the multitasking system. What is difference between multi-programming and multitasking? Both term looks similar, but there is a technical difference between both of them. Some authors also define same. Multi-programming and multi-processing tasking is same, but there is a little bit difference. What is the difference? In case of multi-programming environment, the execution of more than one programs by a single processor by switching between them, that type of environment is simply known as the multi-programming. Okay. Whereas in case of multitasking, the CPU execute the multiple program on the basis of the time quantum value. It means a unique time is shared among each process. Suppose there are three processes, P1, P2, P3. Next four process, P4. We have a small time quantum, suppose 2 milliseconds. Okay. So once the CPU had happened in case of multitasking or time sharing operating system, from according to the value of this time quantum, at first for 2 milliseconds, CPU execute process P1. Now, after this time quantum is completed, CPU will switch to the next process P2 and will start to execute it. Okay. Again, for next 2 milliseconds, CPU will execute the process P2. After that, CPU will switch to the next process P3. Then again, for 2 milliseconds, it will execute process P3. Then again, for P4, it will execute 2 millisecond process P4. Okay, so after this, these process will submit it to the ready queue. Okay, again it will fetch the process P1 and start it up to its completion on the basis of that value of time quantum. So in case of sharing operating system, CPU execute the multiple programs or multiple process on the basis of time sharing manner. It means a unique time quantum is shared among all the process. So this is the main concept of the time sharing system, and that is why this is also known as the multitasking, which is the logical extension of multiprogramming. It means multitasking support the multiprogramming. Multitasking will be the multiprogramming, but it is something extra. And what is something extra? That is it use the concept of the time quantum for the executions of multiple program in multiprogramming environment. Okay, so this basically there is a CPU scheduling algorithm that is known as the round robin CPU scheduling algorithm, and this concept is used in this CPU scheduling. So in time sharing system, round robin CPU scheduling algorithm is used. Okay, so time sharing or multitasking is a logical extension of multiprogramming, and CPU execute the multiple process in time sharing. This is the time sharing operating system. The advantage of time sharing operating system is that it provides the quick response. It means response time of a particular process is reduced. Okay, CPU idle time is reduced. It means CPU utilized properly. There's some disadvantage is that problem of reliability and questions of security and integrity of user program and data, and sometimes problem of data communication. But in time sharing system, if we want to reduce the responsive time of the process, then we use the time sharing system. Okay, this is the another diagram for the time sharing system. Whatever I have defined here about the time sharing system, that is in context to the process, multiple process. We can also define the time sharing system in context to the user. Suppose there is a system and more than one user access those system. They use those system. So what happen? This unique time quantum, whatever the value of time quantum, that particular time will be shared among each user. It means for the first 5 millisecond, CPU will execute the program of user 1. After, for next 5 millisecond, CPU will execute the program of user 2. Then for next 5 millisecond, CPU will execute the program of user 3. And after that, CPU will execute the program of user 4. And after that, CPU will execute the program of user 5 for next millisecond. It means the time quantum is shared among the users. So we can define the time sharing system in context to the multiple process also, and we can also define the time sharing system in context to the multiple user when there are more than one users of a particular system. Okay. Next is the multiprocessing system, multiprocessing operating system. So what is the meaning of multiprocessing? There are three terms: multiprogramming, multitasking, and multiprocessing. These three terms look similar, but there is a difference. Multiprogramming means normal execution of more than one process by a single CPU by switching between them. That is the multiprogramming. Multitasking is the logical extension of multiprogramming. It means multitasking is multiprogramming, but something extra. It means unique time quantum value is shared among all the process, and multiple processes are executed in time sharing manner by a single processor. But what happens in case of multiprocessing? In multiprocessing, it is also multiprogramming, but something extra. What is that? We have more than one process, P1, P2, P3, P4. But in this case, in this scenario of multiprocessing environment, these multiple processes will execute on multiple processor, on different processor. It means execution of more than one program, execution of multiple program on different processor. Such type of environment or such type of processing is known as the multiprocessing. Suppose we have four processor, CPU1, CPU2, and CPU3, and CPU4. Okay, so process P1 is assigned to CPU1, process P2 is assigned to CPU2, process P3 is assigned to CPU3, and process P4 is assigned to CPU4. So if we want to achieve the 100% parallelism, it means we say that the execution of multiple program at the same time or simultaneously, that is happen only in case of multi-processor environment. It means when we have more than one processor to execute. Why a single processor 100% parallelism cannot be achieved? Okay, so such type of processing environment, execution of multiple process on different processor, that is known as the multiprocessing. We can also define it in context to a single process. Suppose there is a large process P1 and this process is divided into sub process. Those sub processes are we have a single process P. This is subdivided into three process P1, P2, P3. Now these subtasks or these sub process can be assigned to different processor CPU1, CPU2 and CPU3. Okay, so execution of a different subtask of a particular process on different processor, that is also a scenario of the multiprocessing environment. And multiprocessing is basically of two types. First one is the symmetric multiprocessing and second one is the asymmetric multiprocessing. So in case of symmetric multiprocessing operating system, definitely there will be more than one processor, but all the processor are treated as equally. It means their configuration will be same, their capability or capacity will be same, and each and every processor can run the task of the operating system. Each and every processor share the same copy of the operating system in case of symmetric multi-programming and multiprocessing environment. This is the basic diagram of symmetric multiprocessing environment. There are more than one processor, processor 1, processor 2, processor 3, and they processor shared a common memory. All the processor 1, processor 2, processor 3, they will share a common memory and a system bus. They will communicate. They can communicate with each other through a system bus. So in case of multi-processing environment, all the processor will treated equally, and they will be of same configuration, and they will access the common memory. They will use the common memory and system bus for the purpose of communication. Whereas in case of asymmetric multiprocessing, this is the basic diagram of asymmetric multiprocessing. In asymmetric multiprocessing, one processor will act as the master processor and other processor will act as the slave processor. Suppose this is processor 1, this is processor 2, and this is our master processor. So this is the responsibility of master processor to assign the task for the slave processor. In case of asymmetric environment, the configuration may be different, or the master processor may be of high configuration. Okay, so this is the responsibility of master processor to assign the task to the other processor, which are slave processor, for the execution, and only the master processor can run the OS task. It means only master processor has access to the operating system. Slave processor will do the task which is assigned to them by the master processor. Okay, and in case of slave processor, asymmetric multiprocessing, more than each and every processor can also have its memory. Each processor can have memory, can be shared, and each processor can also have its memory. Okay, so this is the asymmetric multiprocessing. Some basic differences between the symmetric and asymmetric multiprocessing are listed here in this table. In case of asymmetric multiprocessing, all the processors are treated as equally, whereas in case of asymmetric multiprocessing, all the processors are not treated as equally, because one processor act as the master processor and other processor are act as the slave processor. Okay, tasks of operating system are done individual processor in case of symmetric processing, whereas in case of asymmetric, only the master processor can access the OS. So OS task can be executed by the master processor in case of asymmetric. Okay, in case of symmetry, all the processor communicate with another processors by the shared memory. Okay, whereas no communication between the processor, as they controlled by the master processor. Each processor have its own memory. In case of symmetric multiprocessing, the process is taken from the ready queue. In case of asymmetric multiprocessing, process are master slave process. So these are some differences. Next one is the real-time operating system. Real-time operating system is basically used in the scientific applications. Generally in our personal computer we don't use the real time system. Okay, so real time system is required where there is a significance of each millisecond. It means there is a fixed time deadline to complete a particular task. In case of real time system, every process has a fixed deadline, or fixed, you can say that strict time constraint. Strict time constraint to complete a task. Suppose we have 4 processes, so each and every process has a strict time constraint, a deadline to complete that particular process. Now there will be two things: either that process will be complete in that time constraint, or that process may be delayed. It means that process will not complete the defined time constraint. So on the basis of execution of process in context to time constraint, the real time system is divided into two parts. First one is the hard real time system, and second one is the soft real time system. So in case of hard real time system, the allocated task or process should be completed within the fixed time constraint, otherwise system may fail. It means if the process will not complete the defined time constraint, then system may be fail. For example, there some example where the hard real time system are used are the flight control system and satellite launching system. Okay, so such type of application there is significant of each and every millisecond. So if the task doesn't complete within the defined time, then overall system may crash or your system may fail. Second one is the soft real time system. That strict time constraint is also there, fixed time constraint is also there. But if the process or task doesn't complete within that fixed time constraint, then system doesn't fail. Performance of the system may be degraded, but system doesn't fail. It means that delay may be tolerable. So if the process or task doesn't complete within the fixed time constraint, then that delay may be tolerable. Performance of the system may be degraded, but overall system doesn't fail. Like sending audio, video, or normal personal computer system. Those are the example of it. Okay.